Welcome to Math Advice. In this video, let me discuss an example under Runge-Kutta method of fourth order. That is, how to solve a given problem how to find the solution of a given problem using Runge-Kutta method of fourth order. Before that, let me have a short look over the formula that we are going to use for calculating the successive increments in y. So now, let me first consider the given function, that is a given first order ODEs of the form dy by dx is equal to f of x comma y with y of x naught is equal to y naught. This is for the general form of the given function along with initial condition. So the initial condition is given along with the values of x naught and y naught. Now, look at here. We calculate the successive increments using this formula, that is yn plus 1 is equal to yn plus k and xn plus 1 is equal to xn plus h. This is understood, so no need of a separate formula required for calculating the successive increments for x. Let me explain this in detail here. So your x naught value is given and y naught value is also given along with the given equation. So you have to calculate the first increment x1 and also the first increment y1. So for calculating x1, you have to, so you know the length of the interval h. Okay, h is nothing but the length of the interval. So you have to add x naught with h, that gives you the value of x1, right? x1 is equal to x naught plus h. So if you replace n by 0, what happens? N is equal to 0. Suppose if we make use of this formula, x naught plus 1, that is equal to x naught plus h, which implies x1 is equal to x naught plus h. And if you note this again, x2 means what happens? You have to add x1 with h. So that is, you have to replace n by 1 means what happens? x1 plus 1 is equal to x2 plus h, which implies x1. x2 is equal to x1 plus h. So if you add the previous approximation of x along with the length of the interval, you get the current value, okay, of the x, right? So no need of having the separate formula for calculating x1, x2, etc. But this is not the case for y1 and y2, right? So for calculating y1, so we make use of this formula yn plus n equal to yn plus k. So for calculating y1, you have to replace n by 0. If you replace n by 0, what happens? y1 is equal to y naught plus k. You know the value of y naught that is given along with the problem itself. So y naught value you know, but you don't know the value of k. So what happens? So for calculating k, we need the values of k1. This is the formula used for calculating k. K is equal to 1 by 6 of k1 plus 2k2 plus 2k3 plus k4. So for calculating all these values, we need these formulas, right? k1 is equal to, first let me read the general formula. k1 is equal to h f of xn comma y1 yn, k2 is equal to h f of xn plus h by 2 comma yn plus k1 by 2, and k3 is equal to h f of xn plus h by 2 comma yn plus k2 by 2, and k4 is equal to h f of xn plus h comma yn plus k3. So for calculating y1, suppose if you are going to calculate y1, what you are going to do? You just replace n by 0. So now you replace this xn and yn by 0, that means, so if it is for y1, k1 is equal to h f of x naught comma y naught, isn't it? Just replace this n by 0. And for calculating k2, you replace these n by 0 and simplifying the value, you get to get the value of k2. And for k3 2, you just replace this value of n by 0, and to get the value of k4, you have to replace this value of n by 0 and simplify to get the value of k4. After calculating all these values, substitute in this formula of k, you get the value of k, and y1 is equal to y naught plus k. Now you know the value of k, so which gives you the value of y1 here, right? Suppose if you are going to calculate y2, that is the next increment, what you are going to do? We make use of the previous increments. Listen carefully. For calculating x naught, y naught is given So x1 we just add x naught with h, you get x1. Y naught is nothing but y1 is equal to y naught plus k. So after calculating y1, suppose if you want to calculate y2 means we make use of the previous approximation x1 y1. For calculating y1 we make use of the previous, that is initial approximation x0, y0 and h value. And for calculating y2 we make use of the previous approximation. What is the previous approximation of y2? That is x1, y1 and h value, right? Now for calculating y2, so this is the formula, yn plus 1 is equal to yn plus k. So for calculating y2 you replace n by 1, right? If you replace n by 1, what you get? y2 is equal to y1 plus k, right? You know the value of y1. Just now we calculated by just replacing n by 0 for calculating k1, k2, k3, k4 and calculate k and substituting y1 is equal to y0 plus k, you get the value of y1. Okay, this is what the procedure we have followed to get the value of y1. So for calculating y2, what you are going to do? So here itself we calculate the value of k. For that we make use of the same formula. But only the difference is, instead of replacing n is equal to 0, here you have to replace n by 1 for calculating k1, k2, k3 and k4. That is the only difference, right? So hope you got a clear idea about this. So with this short introduction, let me now move into the problem. Using RK method, that is Runge-Kutta method of fourth order, find y of 0.1 and y of 0.2. For the initial value problem, dy by dx is equal to x square plus y square, y of 0 is equal to 1. So as I told you already, this is the general form of equation along with initial condition. That is dy by dx is equal to f of x, y with y of x naught is equal to y naught. Let me write down here. So dy by dx is equal to f of x, y with y of x naught is equal to y naught. So what is given in our problem? Given in our problem is dy by dx is equal to f of x, y. So that is nothing but x plus y square and y of 0 is equal to 1. I just write down this equation along with the condition here. So what is here f of x, y? So f of x, y is x plus y square. And what is x naught? Y of x naught is equal to y naught. So your x naught value is 0. So your x naught is 0. And what is your y naught? Y naught value is 1. Right? Y naught is equal to 1. So your f of x, y is x plus y square. X naught is 0 and y naught is 1. So let me draw a line and that gives you a clear idea about this. So x naught is equal to 0 and y naught is equal to 1. And what is the question here? So the question is, find y of 0.1. Find y of 0.1 means you have to calculate the value of y at x is equal to 0.1, right? So at x is equal to 0.1, you have to calculate the value of y. And one more question is here. Y of 0.22. Y of 0.2 means what is meaning? You have to calculate the value of y at x is equal to 0.2. So at x is equal to 0.2, you calculate the value of y, right? So these are all the two y values you are going to calculate, right? So at x equal to 0.1 and at x equal to 0.2, what is the value of y? So this is the initial point, the initial approximation, x naught, y naught, 0. So next approximation, look at the value of initial value of x naught and this x 0.1. So what is the difference? 0, 0.1, 0.2. What is h? Length of the interval, that is I understood 0.1, isn't it? h. 0 plus 0.1, 0.1. Next 0.1 plus length of the interval. 0.1 plus 0.1, you get 0.2, right? So you take this as the first approximation x1 and y1 and you take this as again approximation x2, y2. Okay. Now, first we calculate the value of y1 first. So for calculating y1, we make use of the previous approximations x0 and y0. Okay. So before that, we have a short look over the formula. This was the general formula. So now what we are going to do here, we have to calculate y1. So for calculating y1, put n is equal to 0 here. What happens? y1 is equal to y0 plus k. So you know the value of y naught, but you have to calculate the value of k. So for that you need the values of k1, k2, k3 and k4. So for calculating k1, k2, k3 and k4, you have to replace the values of n by 0, right? So this, let me now move on to the calculation part. So put a getting as to find y1. y1, or we have to say this as y of 0.1. y1 or the value of y at x equal to 0.1. What is the meaning of this? The value of y at x equal to 0.1, right? So we have to first calculate the value of y1 first. So for that, let me start from the calculation of k1. So k1 is equal to, this is a general formula, h f of xn comma yn. So now put n equal to 0. What happens? k1 is equal to h f of x0 comma y0. What is the value of h? H is nothing but the length of the interval, right? 0.1. F of x0, the value of x0 is 0 and y0 is 1. This is of the form f of x comma y, right? So instead of x you have 0 and instead of y you have 1. What is the given function? F of x comma y equal to x plus y square. So I have to write this as f of x comma y as x plus y square means 0 plus y square is 1 square, right? So that is 0.1. 1 square is 1 itself. So your k1 value is 0.1. So the value we calculated k1 is 0.1. Next we calculate the value of k2. This is the general formula. In this formula you have to replace n by 0. If you replace n by 0, what you get? k2 is equal to h f of x0 plus h by 2 comma y0 plus k1 divided by 2. So that is equal to h is nothing but 0.1 f of x0. x0 value is 0 plus h by 2, that is 0.1 divided by 2 comma y0. y0 value is 1. 1 plus k1 value just now we calculated 0.1 divided by 2. Simplifying this, that is 0.1 f of 0.1 divided by 2 is 0.05, isn't it? Here 0.1 divided by 2 plus 1 is 1.05. So instead of x here you have 0.05 and instead of y you have 1.05. Given function is of the form x plus y square. So 0.1 x, what is your x? 0.05 plus y square, that is 1.05 square, right? So simplifying this using calculator, you get the value of k2 as 0.1153. Correct? You have to take up to 4 decimal places, that's enough, right? So next we calculate the value of k3. So this is the general formula we have used for calculating k3. So here you have to replace n by 0. So if so, k3 is equal to h f of x0 plus h by 2 comma y0 plus k2 divided by 2. So this is equal to h is 0.1 f of x0. The value of x0 is 0 plus h is 0.1 divided by 2 comma y0. The value of y0 is 1. 1 plus k2. k2 value just now we calculated as 0.1153. This is the value of k2 we calculated. So 0.1153 divided by 2. Simplifying this you get 0.1. This is your h. f of 0.1 divided by 2 is 0.05 comma 1. Simplifying this you get 1.0577. So that is equal to instead of x you have 0.05, instead of y you have 1.0577. So our f of x comma y is x plus y square, that is 0.1 x. What is your x? 0.05. Y square is 1.0577 square, isn't it? So simplifying this using calculator, you know the value of x k3 is 0.1169. Next we calculate the value of k4. For that we make use of this formula. So here you have to replace n by 0. If you replace n by 0, what happens? K4 is equal to h f of x0 plus h comma y0 plus k3. So that is equal to h is 0.1, f of x0 is 0 plus h is 0.1, y0 value is 1. So 1 plus k3 value just now we calculated is 0.1169. So that is equal to 0.1, f of 0.1 comma 1.1169. Am I right? Instead of x here you have 0.1 and instead of y you have 1.1169. That is, what is your f of x comma y? That is x plus y square. So 0.1 plus 1.1169 whole square. Okay. So simplifying this using calculator, you get 0.1347. So take up to 4 decimal places, that's enough. So we calculated all these values of K1, K2, K3 and K4, and let me substitute in the formula of K, and that is equal to, this is the formula for calculating K. So K is equal to 1 by 6 of K1. Your K1 value is 0.1 plus twice K2. K2 is 0.1153 plus twice K3. K3 is 0.1169 plus K4. K4 value is 0.1347. Simplifying these using calculator, you get the value of K as 0.1165. So this is the value of K we have calculated. Next, you know the general formula for calculating yn plus 1, that is equal to yn plus k. So here you have to replace n by 0. If you replace n by 0, what you get? y1 is equal to y0 plus k. So you know the value of y0. What is the value of y0? 1 plus k is just now we calculated, that is 0.1165. That is y1 is equal to 1.1165. y1 or y of 0.1, that is the value of y at x equal to 0.1 is 1.1165. So the value of y1 we have calculated here as 1.1165. So this is the value of y1. Next we calculate the value of y2. So for calculating value of y2, we make use of the previous approximation, that is x1 and y1. So you know this is the general formula for calculating yn plus 1. Next, for calculating y2, you have to replace this n by 1. So for calculating y1, you have to replace n by 0. For calculating y2, you have to replace this n by 1. If you replace n by 1, what happens? y2 is equal to y1 plus k, isn't it? So for calculating k, we make use of this same formula, but for calculation of k1, k2, k3, k4, you have to replace n by 1, not n by 0. In the previous case, we have to replace n by 0 for calculating k1, k2, k3, k4, but here we have to replace n by 1 for calculation of k1, k2, k3 and k4. That is the only difference, right? So now, let me move on to the second part for calculating y2. So for calculating y2, as I told you already, make use of the previous approximation x1, y1 and h. Okay, so let me start the calculation first for calculating k1. K1 is equal to h f of x and y, and this is the general formula. Here you have to replace n by 1. Okay, if you replace n by 1, what happens? K1 is equal to h f of x1 comma y1. What is your h? 0.1 f of x1. What is your x1? 0.1. And what is your y1? Comma 1.1165. This is of the form f of x comma y. So what is the given function? F of x comma y is equal to x plus y square. So that is equal to 0.1 x. X is 0.1 plus y square is 1.1165 square. So that is equal to, simplifying this using calculator, you get k1 is equal to 0.1347. Okay. Next we calculate the value of k2. This is a general formula. In this formula, you have to replace n by 1. If you replace n by 1, what you get? K2 is equal to h f of x1 plus kh by 2, comma y1 plus k1 divided by 2. So that is equal to h. What is your h? 0.1 f of x1. What is your x1? 0.1 plus h is 0.1 divided by 2. And y1 value just now we calculate as 1.1165 plus k1 value just now we calculated as 0.1347. 0.1347 divided by 2. Okay, so that is equal to 0.1 f of, so simplifying the first term you get 0.15, comma simplifying the second term you get 1.18385. so this is of the form f of x comma y. So you know f of x comma y is x plus y square, that is 0.1 x. What is your x? 0.15 plus y square is 1.18385 square. So simplifying this using calculator, you get the value of k2 as 0.1552. Okay, this is the value of k2 we have calculated. Next we calculate the value of k3. So this is general formula. In this formula you replace n by 1. If you replace n by 1, what you get? K3 is equal to h f of x1 plus h by 2, comma y1 plus k2 divided by 2. That is equal to, what is your h? H is nothing but 0.1. F of, what is your x1? x1 is 0.1 and h is 0.1 divided by 2, comma y1 is 1.1165 plus k2. Just now we calculated the value of k2 as 0.1552. So 0.1552 divided by 2. So simplifying this you get 0.1 product f of, simplifying the first term you get 0.15. Comma, while simplifying the second term you get 1.1941. Okay, so instead of x you have 0.15, instead of y you have 1.1941, that is 0.1. f of x comma y is nothing but given function is x plus y square. So 0.15 plus y square is 1.1941 whole square. So simplifying this using calculator you get the value of k3 as 0.1576. Okay, so next we calculate the value of k4. So this is the general formula. In this general formula you replace n by 1. So if so, k4 is equal to h f of x1 plus h, comma y1 plus k3. So you know the value of kh, that is 0.1. F of x1 is 0.1 plus kh is also 0.1, comma y1 is 1.1165 plus, I don't have space here so I have to write it here, k3 is 0.1576, 0.1576. So that is 0.1. F of adding these two values together you get 0.2, comma adding these two values together you get 1.2741. So this is the form f of x comma y. So f of x comma y is nothing but x plus y square, isn't it? That is what the given function. So what is your x? 0.2 plus y square is 1.2741 square. So simplifying these using calculator you get the value of k4 as 0.1823. So now substitute all these values of k1, k2, k3, k4 in equation, that is in k. So k is equal to 1 by 6 of k1 value we calculated as 0.1347 plus twice k2. k2 is 0.1552 plus twice k3, that is 0.1576 plus k4, that is 0.1823. So simplifying these using calculator you get 0.1571. So this is the value of k. So you know the formula for calculating yn plus 1, that is equal to yn plus k. So in this formula, we just replace n by 1. If you replace n by 1, what you get? So replacing n by 1, you get y2 is equal to y1 plus k. What is your y1? Y1 value is y1 plus 1.1165 plus k value just now we calculated as 0.1571. Adding these two values together, you get the value of y2 as 1.2736. So y2 or y of 0.2, which means the value of y at x equal to 0.2. The value of y at x equal to 0.2 or y2, both are same. So we calculated y2 value as 1.2736. So we calculate both values, that is y1 or y of 0.1, that is equal to 1.1165. Okay, this is the value, and y2 is equal to y of 0.2. y2 or the value of y at x equal to 0.2, that is equal to 1.2736. We calculate both of these values using RK method of fourth order. Hope you got a clear idea about how to solve the given initial value problem using RK method of fourth order. Thanks for watching. See you all again in my next video.